Hi, everyone. My name is Tracy Tober. I'm the chair of CGIA. I just wanted to tell you a little bit about it. I'm going to share. Yeah, I can't share my screen. Anyway, CGIA is a nonprofit
Go
that.
ahead, share.
Okay, thank you. I'm just going to show the website. Okay. So CGIA, which stands for California Geographic Information Association, is a nonprofit that formed in 1994 to facilitate coordination, collaboration, and advocacy for California's geospatial community. And sorry about that. I just wanted to thank our sustaining members for supporting us. And if you're interested in joining CGIA, you can click this little button, or if you have any questions or comments, you can chat at me during the webinar or email me at chair@cgia.org. And I'll turn it back over to Jane. Thank you.
Okay. All right. Do we have any other upcoming events, CGIA, that we're ready to announce? I know we got some webinars in the queue.
We are working on some webinars. We have not solidified dates, but we're doing
Okay.
a four-part series on GIS and AI.
Awesome.
One
Looking
up at the
forward to
end of
that.
March.
Wonderful.
Yeah.
All right. So sign up on the website to get on the email list so you won't miss any of that. Okay. So we're going to jump into the agenda, and start with the presentations. I'm going to start with a very quick overview of the stewardship of hydrography in California, and then I'm going to turn it over to two different USGS speakers. One will be Cynthia Miller, who's our National Map Liaison, and then Dave Blodgett, who's one of the brains behind 3DHP. And then we'll turn it over to our partners at California State University, Chico and Northridge, who have been very hands-on with the development of hydrography in California. And then we're going to have Colleen McNally Murphy, who's with the San Mateo Resource Conservation District, who's project manager for a collaborative project mapping 3 counties in the South Bay. So I'll just jump right in now and share my screen and hope this works. Okay. Okay. Are you seeing presenter the correct screen?
Yes.
Yeah. Okay, great. All right. So here's a quick intro to my department's role as steward of the California portion of the National Hydrography Dataset and the partnerships that make it all happen. I'm the technical lead for stewardship um, of this data, which is contributed to the U.S. Geological Survey's national map. And drought was how our program got started. The drought crisis in 2014 was declared an emergency by the governor, and that brought the opportunity through the California Water Action Plan to highlight the need for national hydrography data set stewardship. It got funded and the program's underway, and I was hired as the technical lead in 2015. But data stewardship is indeed a team effort. From the start, we've partnered with the geospatial centers at CSU Chico and CSU Northridge to get the work done. We've updated the NHD throughout the state to the 1 to 24,000 scale, and then updated the watershed boundary data set to match the hydrography. But even before our program got funded, the California Department of Fish and Wildlife contracted with these CSU centers to incorporate their lakes and streams data into the national map. And then U.S. Forest Service was updating NHD in some of their forest units. And the Los Angeles County Public Works Department uh, jumped in the mix here to fill in what was then a void in flowline connectivity in the urban LA basin. And then later on, Redwood National Park and Marin County Collaborative contributed work at the 1 to 5,000 scale. You can learn more about our program, find where you can get the data, and a whole lot more information about our stewardship of national hydrography data, including some information on 3D HP as it's developed at the California Natural Resources Agency open data site. I'll put that link in the chat. Just type NHD in the search and you'll get to that page. All right. Now, according to a study of hydrography data user requirements conducted by USGS in 2016, users need data that aligns with the surface of the Earth as represented in LiDAR digital elevation models, which are now available for California and most of the US. The users want elevation values included in every feature to accurately model the flow. They want to know where the barriers to flow are and how the water flows through, around, or underneath those barriers to get from the headwaters to the sea. They need something better than the NHD. So in 2021, USGS released its call for action to create a 3D national topography model, starting with the 3D hydrography program. Our role as data stewards was changing. With our CSU partners, we've embarked on a pilot project to customize existing hydrology tools and write new tools to produce elevation-derived hydrography data that meets USGS standards, contributed to the 3DHP, and share publicly the tools and documentation of our work. We started the pilot work with a group of watersheds in Los Angeles County, and additional watersheds in the northern part of the state have been added. Our team is confident that the data will eventually be accepted by USGS for the 3DHP. And these are the other watersheds included in our pilot work: 2 forested areas along the North Coast and 2 others in the Northeast foothills and Sacramento River Valley. We submitted a cost share proposal to USGS, and in early 2025, we were awarded the grant to create elevation-derived hydrography for the Upper Feather River watersheds, which are the headwaters of the State Water Project. This work is being done by our CSU partners under a cooperative agreement with USGS. DWR and CSU agreed to deliver the elevation-derived hydrography that meets USGS standards, and USGS agrees to ingest it into the 3DHP. And there were 2 other California projects submitted and awarded for the fiscal year 25 data collaboration announcement. Our CSU teams will not be doing the data work for the other 2. Those projects are contracted by USGS to one of the participating vendors, and in these cases, NV5 was the chosen vendor. These projects span multiple counties and involve many collaborating organizations. Later on, we'll hear more about the Santa Cruz Mountain Project from Colleen McNally Murphy. And here is a very much zoomed out view of all the known projects in planning, proposed, and in production. I don't want to take a lot of time to go into it here. I will make this image available to you. If I can upload it in the chat, I will. Otherwise, I'll send it out afterwards. And be happy to discuss with anyone who's interested in knowing more about how to participate in this. But now I'm going to turn it over to Cynthia Rittmiller, the USGS National Map Liaison for California and a whole bunch of other states, who's going to tell us a lot more about the USGS role in this project.
Hello, everybody. I'm Cynthia Rittmiller, as Jane said, with USGS. I am the National Map Liaison for California as well as several other states. So I'll go ahead and get rolling here just so we can, time's sake. Within USGS, I'm part of the USGS National Geospatial Program, or NGP. NGP provides a foundation of digital geospatial data representing topography, natural landscape, and man-made environments of the United States. Some of the components of NGP you can kind of see on the slide. We do a little bit of everything, but really our primo product or our platform is the national map, which Jane already mentioned. So really, let's focus on what is the hydrography of the national map. First, there is the NHD, or the National Hydrography Dataset. This was the first national surface water data set that was provided. The majority of this is based off the original 7.5-minute topo map, so it was digitized off of that. It is a 1 to 24,000 scale or greater, so it's pretty accurate for kind of local, right, a national data set for that. This does contain modeling and tracing water up and down the stream, but it is an older data set. The next one is the WBD, or the Watershed Boundary Data Set. This established a drainage boundary framework, and so this is made up of hydrologic units, or HUs. This is really where the water can be contained and where we can find the water. The next was the NHD Plus. So this is the NHD Plus high resolution. This was USGS's first endeavor at elevation-derived hydrography. Using the NHD, WBD, and our 3-depth elevation data, we really created the NHD Plus high res. NHD Plus high res provided additional information that was not included in the NHD or the WBD. This included hundreds of attributes, including the value-added attributes. Catchments and rasters were also part of this data set. This provided a more user-friendly data set where users could grab and play with the data instead of having to do the modeling and some manipulation like they previously had to do with the NHD. The NHD and the WBD was built off of a stewardship program, like Jane mentioned, right? 41 states participated in this program, but the updates were not uniform or consistent depending on where we had partnerships and where we didn't. So the national data quality has decreased over time. And then the surface waters, as Jane mentioned, right, don't align well with the 3D-HP or the elevation data there. So we do want to kind of update that data. In 2022, USGS began to focus on 3D-HP or our new 3D hydrography program here. There are static versions of the NHD, the WBD, the NHD Plus, and those are found on our website. They will always live there, but we are moving forward with 3D-HP going forward. So really building on decades of previous hydrography concepts, the 3D-HP is being established to completely refresh the nation's hydrography data and improve discovery and sharing of water-related data. New hydrography will be standardized to align vertically, horizontally, and temporally with the 3D elevation program, or 3-depth. New hydrography will be standardized, transitioning to the hydrography program to 3D-HP allowed us to simplify this data and the resources required to maintain it. This was really a big kind of push from one of our program perspectives, right? Do more with less resources. And so trying to move forward with how can we make better quality data with less resources, knowing that's going to be kind of our transition over time. Estimations to create this program are about $685 million over the course of 9 to 10 years. This is a rough estimate, right? But it is going to be a community effort to move forward with this. Let's briefly look at the 3D-HP data lifecycle just so you can kind of see how the data is acquired. First, we have our planning. So the collection of newly elevation-derived hydrography is going to be accomplished through partnerships, local, state, federal. Everyone needs to be involved here and have a lot of coordination across all platforms. As Jane mentioned, the DCA, or the Data Collaboration Announcement, allows non-federal entities to partner with USGS or to do the work on their own and then get the data in to USGS as well. So here we can kind of see this can be hydrography, this can be elevation, or this can be both projects together for a certain area. It's really finding those partners, figuring out how are we going to collect the data, or how is the data going to be collected, whether that's through our geospatial products and service contract, our GPSC, or whether that's through a co-op or a financial assistance program. The instructions and kind of the submission process is through our DCA portal. You can review that. I'm also happy to answer any questions. So really, as those projects get submitted and move forward for proposal, you can see it takes quite a bit of time from the time that project is submitted to when that data actually can be started to be produced or actually moving forward there. So typically those DCA proposals are submitted in the late spring or late summer rather. So that's August, September. And then moving forward, USGS will review those and decide based on our funds, can we support those whichever contracting method, whether it's GPSC or through a co-op agreement. And then really those get pushed out. Funding is always uncertain, right? Depending on the year. So this is always kind of questions that we get moving forward. Part of that planning could be reaching out to your national map liaison. I'm always available to answer questions. I can provide cost estimates. I can provide suggestions or questions. It could also be, hey, is anyone looking in my area, right? Those are things that we can easily kind of just see. Is that something that is worthwhile? Maybe there's 2 partners or someone else that you didn't know about. And I'm happy to connect people there. Acquisition is going to occur on the 3D-HP data. So we've submitted our DCA, we've been reviewed, that project has been awarded. We're moving forward and going to acquire that data. As data is acquired, it is required to meet the USGS elevation-derived hydrography specifications. These are found on our website. They are updated semi-frequently, but not too often where you can't kind of follow along. I'm not the expert here, but I can definitely help answer questions or point you to those who are experts. The 3DHP partnerships, so this is our FY25 map of all of the partnerships. We don't have an FY26 yet, but we'll find those as partnerships occur, those will be added here as well. Then we have validation. Validation includes performing quality control checks on the source elevation-derived hydrography supplied from the contractor. USGS is going to validate the network, the XYZ values, double check all the features are in the correct feature type. I also added a little bubble here where there is ingestion into 3DHP. I'm not going to talk about it, but this is really where 3DHP becomes what it is. This is where additional attributes are added, including flow network derivatives, or FNDs, catchments, main stem network, and GNIS IDs, which Dave Blodgett's going to talk to us about. The 3DHP is going to be primarily provided through a map service and an annual downloadable product. This was also a huge program change for us, right? But one of the major benefits of doing services is ensuring everyone has the same data at the same time. And then really probably the most important part of this workflow is really how do users get the data, right? USGS has published 2 services so far. We have a web map service. We also have a web feature service of 3DHP. And we have an annual downloadable product that has been pushed forward. So our services you can find under the theme overlays. You scroll all the way down to the bottom and you'll see those 2 listed there. You can also find our stage product through, my favorite way is through Sciencebase. It's just a catalog, or you can find it on our access page. Here we can look at the 3DHP service. If you've used NHD or NHD Plus before, you can see that this data model is much simpler. We still have points, lines, and polygons. We still have features on the data, but it really does define what does the user need and how can we really leverage that as a nationwide data set. There is also a drainage area feature class on here, which is going to be similar to the WBD. So that will be populated as we kind of go through the country and update 3DHP. That's all I have, Jane. I'll pass it over to Dave, or I don't know, Jane, if you want to say something in between.
Yeah, sorry, I was muted. Okay. Yeah, thank you so much, Cynthia. If questions pop in your head, please feel free to put them in the chat anytime. We'll converse on the side there. But right now, we're going to move over to Dave Blodgett. I asked him to come and talk about what's so special about 3DHP data. So take it away, Dave.
Ooh, all right. Well, thank you for having me. Really tickled to have this audience, 120 people on. And you are my people, big time. And Cynthia is trying to tell you that she doesn't actually know all the things. She knows way more than most people do. So don't let her get away with that. But I want to share this screen here, I think. Share. Yeah, all right. So Cynthia and I didn't really coordinate, but this is a great handoff. And I thought I was going to have some material that was what she was going to talk about. Turns out she covered kind of an important component of all of this that's different from what I'm going to cover. So before I dive in, get all ahead of myself here. My name is Dave Blodgett. I am a acting branch chief right now in the water mission area here in the USGS. The water mission area is a separate headquarters organizational unit from where the National Geospatial Program sits. NGP is within a mission area. We call our mission areas. It's within a core science systems mission area, and the group I'm part of is in the water mission area. And so we're pretty distinct units within the survey, but we have a totally shared and coupled and codependent mission when it comes to hydrography in particular. And so there's a long and storied and somewhat sordid history between the groups that have fostered the national map, the NHT, et cetera, and basically and the National Water Information System and the various kind of assessments and things that have gotten on in water in the USGS. I'm on the water side of the house. Cynthia's on the geospatial side of the house. So that said, I did a detail for a better part of a year to help with the design and kind of genesis of 3D HP, and have been in and around this stuff for the better part of my career, working on geospatial topics in water resources. So that's my background and just kind of where I'm coming from. And so just kind of takeaways up front, right? And this is my totally biased perspective, but I think I feel this is correct. The biggest gee whiz with 3D HP is that it's elevation integrated. I've had a lot of pretty angsty conversations with groundwater modelers about the NHD not being elevation integrated. And it's close, but it's not close enough for some applications that really require our estimates of where water is essentially, or would emerge if there were water there, and how the elevation aligns, right? Those two things need to be in unison. And so that as a capability with a goal of having it be nationwide is really profound. Actually, it's pretty exciting. The second thing is 3D HP it's at the heart, and to some people's eye, it is the heart of water data on the web now. And I'll show you what I mean by that, because it's Cynthia mentioned main stem network integration as part of 3D HP ingest. That main stem network is the backbone identifiers that we're using for the Internet of Water and the kind of most broadly water information on the internet. And to me, the big profound thing there is we've broken out of the geodatabase with this project. For a long time, hydrology, geospatial in general, was trapped inside the confines of individual geodatabases, and breaking out of that with identifiers that are linked to the internet and give us an opportunity to create more dynamic, more cacheable, advanced data systems is really significant. And then the last thing here is that 3D HP, it supports advanced analytics, analyses, analytics, et cetera, out of the box. And the key thing there is we're not starting from a hydrography and building advanced analysis capabilities on top of it. We're building a data set that can do these things as designed, as built. Where NHD had NHD plus, 3D HP is just 3D HP. That's a big deal. It's really important that we're kind of coming back to the basics and saying, no, we're going to do this as a complete thing from the ground up, right? And that's really significant. So Jane, that's the answer to your question. That's the answer to the question of why you asked me to come. So I can stop now. But so now I'm going to go into a few specifics about the kind of 3D HP program and how it relates to kind of the historical data and kind of substantive issues about the program. And then I'll see how much time I have left toward the end. I've got a number of demos and resources that I can share toward the end. Okay, so the history here is, I find fascinating. The NHD goes back to the 40s and before, when we were out on the landscape observing elevation and where water was on that elevation. And through the years, it evolved some, but we always had bits and pieces of that original practice of surveying the landscape for where water was. And it was essentially a cartographic observation, the NHD was. And we bolted everything we could have possibly imagine onto that cartographic observation until we got to NHD plus high res, and realized this is great, but it's not. There's still some issues, right? We need to go fully elevation integrated. And so that's this new era, right? We're going to 3D HP, systematic remapping of the nation's hydrography based on elevation integrated hydrography. And we're looking at three categories of users here. And this is another thing that it's hard to bolt modeling users and network users onto an observational cartography product. And so that was always clumsy in NHD, right? But we can do it as a matter of first principles in 3DHP now, where we have modeling as an application upfront as this thing is designed for that, right? Same thing with the network, people that need to, and this was always the application, the use case that EPA had. RF1 was a data set to index water quality to, so EPA could keep track of all the information they had to track across the country, right? And so fast forward, NHD plus, NHD plus high-res have these use cases baked into them, modeling and network, and it was bolted onto NHD. Now we've got them all three combined. So I guess the other nuance to call out here, and this isn't necessarily a user type, but hydrology as the organizing principle is really, really important. And this was one of the big things that came out of this hydrography, the hydrography benefits study. I forget the HRSB, hydrography requirements and benefits study. This table on the right is the outcomes of that study. What came out of it was that a hydrologic basis is critical, right? Everybody needs this thing to follow hydrology for their hydrologic applications, and everything kind of follows from that. So the 3D hydrography is in there were a lot of decisions. There were a lot of decisions that were made that were hydrology dictates that we have to do it this way, right? And that really was our guiding light. So accuracy, precision, all of that. If you haven't looked at this data and played with it yet, you didn't know that NHD had these precision issues because it looks pretty detailed till you see 3DHP and you're like, oh, right. there's another dimension here almost, and there is another dimension. There's a Z dimension, but there's also this additional real fidelity in the spatial plane that we're almost not we almost didn't know that we were missing. So then where are we at with acquisitions on this? And the acquisitions tells one story, and the graphic that Jane was sharing earlier in California shows some of that. The maybe less exciting story is that production is a little bit less. Where have we started, or where are we working on production? And where have we actually published data is even less. And we've got lots of excuses. If you want to talk excuses, I am full of them. But seriously, there's momentum. I think the takeaway here is there's real momentum across the country to get data into the pipeline. There's real momentum in the pipeline, and we've shown some success. And these data sets are working; they function. And there have been a lot of headwinds in the last couple of years to make progress in the space we exist in. But despite that, I think we are really showing that this can happen, and we just need to keep pushing. So, okay, so I'm going to jump into the products and just show you a few things. But the big thing to note is this thing is services first, in the sense that regular quarterly releases are going to come out as services, not as staged download products. So if you want the laytest 3DHP, you're gonna use the services. It may be to create a subset file yourself, but you're going to use the services. But there will be static point-in-time snapshots that are released annually for applications that need stability. And that's always been one of these big challenges. Everybody wants the latest update, but everybody also wants the data set to never change. And there's conflict there, right? So striking a balance here, annual snapshots feel like a reasonable thing to do, giving people a point in time that they can say, I used that year's snapshot for my system. I plan to update every 5 years, and I'll use the latest 5-year snapshot, and that's just the way it is. Other people are going to say, I want the very latest EDH that was released because I just contributed to the collection and processing of an EDH zone, and I need it right away. So we want to be able to support both, and that's how we're doing it. Okay, so from here, I'm going to jump over to a browser window. And Jane, can you give me a time check? How long do you want me to go for here?
Yeah, you got 10 more minutes.
Okay, great. Wonderful. I just got to figure out which window. Okay. So I said that 3DHP is kind of one of, if not the backbones of the Internet of Water. And I want to start with this application called explorer.geoconnects.us. And some of you may not be familiar with GeoConnects. GeoConnects is think of it like the digital object identifier infrastructure for the Internet of Water and other online environmental data infrastructure. So we set up geoconnects.us so that we could track unique identifiers for things in the world, but through the internet. So the demo I want to show you is I'm going to come in here and search for the Stanislaus River. So I just put in STANI, and I got 3 Stanislaus rivers, a North Fork, a South Fork, and a main fork, I guess. And you can see each of them has a URL that goes along with it.
Hey, Dave, we're still seeing your PowerPoint.
No, thank you for interrupting me.
Yep.
I meant to share my whole. Let's try this again. I thought I was sharing my whole screen. We're going to go that application window, share. Fortunately, I wasn't like waving my mouse around too wildly. I was just talking at a blank screen. So we're going to go back to the beginning of explorer.geoconnects.us. To get here, you get a little blurb of what it is. There's an about tab. There's a map. I just type in STANI, and I get the 3 entries that system has for the Stanislaus River. And what I wanted to show you is the Stanislaus River here at results has this. This is actually not a URL. This is a URI, which don't worry about the distinction, but you will never go to a web page that has this identifier. Like a digital object identifier, let me actually copy this. This identifier redirects to a web page about this ID, right? So this is a main stem ID that is baked into 3DHP. It's also a main stem ID that we've indexed a lot of other things to. So there's stream gauges indexed to this. There's multiple versions of hydrography indexed to this. If you want to interoperate between data sets on this river, this is the ID that you're going to start with, right? So that's cool. And so now I'm going to jump over to a demo of kind of what we can do with web services. And so we're going to start from a main stem river ID. And so the 2 things I just showed you was the Explorer identifier with the integer ID for the main stem at the end, or the actual reference main stem identifier itself. And and so I'm going to run through this pretty quickly. Don't worry about the code. I'm just going to talk you through what this code does. Happy to share this as an example down after we're done if folks are curious. But this is using an R package that I maintain called NHD Plus Tools. I'll give some links to this and a Python package that does the same stuff when I'm done here. But so we start from a main stem, and I just say, give me the flow lines for that main stem. It makes a web service request to a national map web service, and it gives me back this line that I can put on a map. And each feature in this line has a bunch of attributes. So this is 3DHP data that I just retrieved for the Stanislaus River, right? And every one of the, and I'm realizing my map isn't going to work great here because there's so many features, but every one of the features has a main stem ID that happens to be the one I was just searching for, and other attributes, right? This is 3DHP data. So then we can come down here and do some other interesting things. One thing, this isn't 3DHP necessarily, but those main stem IDs themselves, they return GeoJSON. So if you're an R user or a Python user, GeoPandas, QGIS will do this. I believe ArcGIS would read the GeoJSON. You can just pass that ID to your software, and it'll go fetch the GeoJSON representation and give you the GeoJSON of the main stem. And then you can start doing things with it. So like in this case, I grabbed the NHD Plus version 2 COM ID of the outlet of the Stanislaus River. And now I know an NHD Plus version 2 COM ID for the outlet of a 3DHP river, which means I can now use NHD Plus v2 derived content in concert with 3DHP, so I'm just kind of demonstrating the power of main stems. And one of the reasons main stems is so useful as a way to tie the internet of water together is all of a sudden I can get the outlet identifier from 3 or 4 data sets and start to pull things from different places and mash them up in meaningful ways. So here this is just the outlet flow line, but I can also get a drainage basin. And here's a drainage basin for that river pulled from NHD Plus version 2. So that's handy because then we can use that as a subset tool to get all the flow lines from this river. And just to show you kind of the scaling here, this is 194,000 features. And so this is just printing out all the web service requests to get the 194,000 features. And here they are, right? My browser's a little bogged with mapping all these. But so here's all the 3DHP features that came back for that basin plus a little buffer, right? So we can now build subset data sets of 3DHP pretty much on the fly in R or Python, dump them out into geo databases, geo packages, and go reuse them for map projects and whatever projects we have that we want to work with, right? So this is, I wouldn't say it's trivial, but this is, once you've kind of got the example of how to do this, it takes 10 minutes, right? This is not a big task. So that's cool. And so then I want to show a little bit of more specific 3DHP stuff. So now we're going to go to a main stem in the Holston River Basin, which is where 3DHP has been processed. And so here I'm similarly grab a main stem worth of data. We've got 480 features, but now each of these features, minor demo fail. I have to actually go to the ones that have 3DHP.
You got a little over 2 minutes left, Dave.
All right, perfect. I'll get there. Okay, so now each of these features has additional attributes that, for those of you who know NHD Plus, these are NHD Plus attributes, right? These are going to allow us to do a lot of the network aware operations that we did with NHD Plus using these new data. And when the data is available in the web service live, it's going to be NHD Plus compatible, and we can actually do some of these really cool applications. So stepping down, we can pull catchments. And keeping on going here, I just wanted to show the last. So here's the whole Holston. Okay, so now we can even do interesting things visualization wise. Here we're using a stream order that's generated as part of NHD, or excuse me, generated as part of 3DHP out of the box. We have stream order. We can use it for visualization. Similarly, we go to here's a demo in here for the Juniata. We can pull all the data for the Juniata for a given Huck polygon. That's kind of our subset unit. We can do this shows how to do network navigation. In the interest of time, I'm going to keep moving. But we can also, based on network traversals, pull subsets. So this is only the network connected flow lines, and we're visualizing a distorted version of arbolet sum, or the total upstream drainage area, total upstream flow line length. All right, so it's real, it's exciting, it's hooked to the Internet of Water. This last little demo is showing stream gauges along this river from 3DHP. So each one of these is a stream gauge that's available in GeoConnects for a feature that's linked to an identifier in 3DHP. That's kind of the coming to some of the really meaningful Internet of Water stuff. As we go forward, things are going to increasingly be indexed to these identifiers that are in 3DHP. And I'll stop there. I was obviously way over ambitious on what I was going to try to cover. I did get to the end of my demo. And I'll drop a few links that y'all can visit in the chat. The first one is a visualization tool that a colleague of mine wrote for visualizing 3DHP data. My tabs are unavailable because of, there we go. Okay. That one I'm not as worried. Okay, so another one is a hydrologic indexing tool called HydroSnap that was just released that will help you get your data indexed to main stem IDs. This was just released 30 minutes ago and is a very first implementation of something that's going to evolve over time. I'll give you a link to this. It should be a really useful tool. It's a very lightweight R-Shiny application for network indexing. High River is like NHD plus tools, but in Python. It can pull 3D HP data from web services and generate subset data sets for you. NHD plus tools has the functionality I was showing just now. I will add this demo to NHD plus tools in the docs folder. So I'll pass along a link to where that's going to be. I haven't checked it in yet, but I will. And those are the links I'm going to share. I got one other thing I was maybe gonna show off, but we'll have to save that for another time or another venue. So that's what I've got.
All right. Thank you so much. Yeah, so you'll be sending me those links and slides and such, and I'll make sure our audience gets them.
Absolutely.
Okay. Sounds awesome. All right. So if you think of questions, put them in the chat, and we're going to move on now to our CSU partners. Okay, we have Eric Fintel from who's with CSU's Chico's North State Planning and Development Collective, and Joel Osuna Williams with the Center for Geospatial Science and Technology at CSU Northridge. Take it away.
Great. Thanks, Jane. Yeah, and thanks for the opportunity for us to be able to share what our roles are in 3D hydro development in California. As Jane said, I'll be presenting today with Joe Osuna Williams. He's at CGST at CSU Northridge. I'm Eric Fintel. I'm at NSPDC at CSU Chico. Some of you might know in the past we're actually kind of known as GIC, but our names changed over time. But yeah, we're just gonna take a few minutes and kind of give you an update of what our roles are and how we're interacting and working with DWR and other folks that are working in hydro development in California. Next slide. So both Joel and my shops, they're GIS research centers at CSU's. The two of our shops have collaboration that's been established where we've been working on projects together for over 15 years. Both of us have been very active in hydrographic data production, specifically in California since 2010. So that would include some pre-NHD work. We were definitely heavily involved in early pilot projects with NHD, with actual production of a good portion of California for NHD. We were also sub-stewards under Jane Schaefer-Kramer at DWR, helping folks with NHD and getting out in the community, doing presentations and demos and producing work. We've recently pivoted to EDH, or Elevation-Derived Hydrography, and 3DHP. So over the last couple of years, Jane showed a slide earlier where we've done some pilot work, and we are now in production work for both of those products. Next slide. So just quickly, super high altitude, general idea of the hydro derivation process. One of the things that we've been working on is building workflows and tools that lead us here. So this is just a super high altitude look at how you get from your starting point to the end, with the end being your data is actually passed USGS compliance checks and it's actually contributed and can get ingested into the national map. So that's the higher, bigger picture of kind of what we're doing. Next slide. And then to kind of give a little more context to it, this is what our current workflow looks like. It's pretty robust. There's lots of steps. It's an iterative process. You have to go through things a bunch of times. So one of the things we've really tried to do, both in our workflows and with the custom tools that we're building, is to build in automation and simplification and ways to just make the process faster, whether that's processing things or just building tools that pass things from one thing to the next. So you're not hitting a bunch of buttons. And specifically in our tools and our QC checks and our compliance checks, where the data needs to go through to get to USGS, we've been building automations in that can fix a lot of these errors. If it can't fix them, it produces reports that allows you to understand what's wrong and go back and look at the data. But I think the thing that we want to highlight most out of the workflows and the tools is that we are working directly with DWR on this. And the idea is that DWR will own these workflows and tools at the end and be able to share these with the general public. Anybody who wants to be working in this space can have access to at least the workflows that we've developed and the tools that, the custom tools that we've done to help you work through that. Next slide. Another component that we've been pretty heavily involved in, and really happy that we had some conversation earlier about the DCA, is that we've been helping DWR with costing, planning, and submission for DCA. Again, it was mentioned earlier as kind of a vehicle where you can partner with USGS and potentially get some cost sharing to help these projects get done. So we help DWR with this process from the planning to the submission. And if it's approved, then we'll work with them potentially to do actually the production of the work. But as part of our role, we're also helping the general community and anybody else who's interested in DCAs. We can help with any of the planning process and share our experiences and just help folks through that process in general. Next slide. And to kind of highlight that, again, Jane mentioned this a little bit earlier, but we did successfully submit a fiscal year 25 DCA proposal that was for the Upper Feather River watershed. So that's all the contributing area above Oroville Dam. That work is currently in progress. We're hoping to have that finished up in the next year or so. And then again, as Jane mentioned, we submitted 2 additional DCA proposals from some other areas in the state. We're currently waiting to see if those will potentially be funded out of the pool of everybody else who put in for a DCA proposal across the nation. If those are selected, we'll be excited and happy to share where the work will be. It's really going to bookend the Feather River project, so it's going to kind of build out this data set over a kind of a nice broad area. But again, part of our role here is to help facilitate all this type of work, communication, presentations, trainings, tool building, just to help DWR and anybody who wants to work in this space. So with that, I'll hand it over to Joel, who will finish up the last couple of slides for the other things that we have going on.
Thanks, Eric. Can you hear me okay?
Yes.
Perfect. Thank you. So in addition to our involvement in data production and tool development and being actively involved in the DCA project, like Eric just covered, we do have a part of our agreement dedicated to assisting DWR with outreach, engagement, and education tasks and efforts. In the last 2 years, especially, we've been involved and have done many technical talks, formal and more informal, and with folks and groups in the state of California and out of state as well. These talks have allowed us to share knowledge and grow our knowledge bank. We've been able to share with other collaborators and other producers of elevation-derived hydrography the status of our tool development, where we are with workflow updates, what challenges we're experiencing. And we see it as a two-way street. We also welcome information from our collaborators and our partners, knowing what their priorities are, what they want to see out of a product as an end user, and what other challenges they're experiencing. Again, growing that knowledge bank in a collaborative way. The DCA has already been mentioned many times already, but we are looking to build coalitions and partnerships, increasing the likelihood of cost sharing opportunities and being involved in the DCA process for 3DHP. And for a state like California, such a large state, even general coordination goes a long way. Just knowing who's interested in what regions, and if certain groups are going to go in for a proposal, knowing that information is really critical for the coordination piece and in order to avoid duplication of effort, duplication of work. And in these engagement events, we also always throw out the need for reference data, a really important reference data that plugs directly into our tools and workflows for producing elevation-derived hydrography, things like infrastructure data, roads and trails, and possibly field collected and validated stream data. All of that's really valuable. And again, we see this collaborative effort as a two-way street where we always welcome reference data from especially local and regional partners. In the near future, we hope to set up a California hydrography portal in collaboration with Department of Water Resources. This platform will be a centralized online application that will allow for product and resource sharing. It'll also allow us to provide news updates and reports through the form of a series of status maps and dashboards. Our vision kind of includes presenting historical information on the NHD updates that were done on the state, the WBD improvements that were done, but more importantly, kind of the current status of elevation-derived hydrography in the state. Where is data being produced? Where are the DCA projects? So that it can assist and facilitate with a lot of that coordination and engagement. We also want to get stakeholders and end users involved through this portal, allowing them to review interim data and giving them the opportunity to provide comments and markups so that the producers of the data, the producers of the hydrography in the state, have an opportunity to take that into consideration and, where feasible, roll it into their production efforts, add that additional polish, make those changes if, again, feasible, before the data sets are finalized and contributed to USGS for 3DHP ingestion. And then another big role that we play is the role of providing technical assistance, not just in data production, but alongside DWR, really acknowledging that there are many data producers when it comes to hydrography in the state. Some of which do have USGS specifications in mind. They have 3DHP as an end goal, either directly or indirectly. And some others don't necessarily think that's a priority, or they're not really thinking about those specifications and contributing to 3DHP. So our role here is to inform and educate. And if there's interest, we are here to provide assistance with assessing those data sets, those hydro data sets, and providing reports and feedback to those groups, letting them know your data set follows these specifications, but it doesn't really follow these other specifications that USGS expects you to adhere to before the data can pass validation and be integrated into 3DHP. So we're here to provide that level of technical assistance in addition to workflow assessment, workflow development. And we've already mentioned this as well. Eric mentioned this, is the tools that we're developing will be public facing. And once they are shared publicly, we are looking to hold several trainings through workshops and webinars so that anyone who's interested in producing their own EDH can learn a little bit about what's involved, not just producing the EDH, but again, making it compliant with USGS specifications. So we're here to provide technical assistance along with the engagement and education piece as well. So we hope that gave you all a quick overview of how we're involved, how Eric's team, my team is involved in hydrography for California. Again, we're working directly with Jane. Our contact info is up on the slide. Before I finish here, I did want to briefly just plug into upcoming events. We are planning on attending the AWRA Geospatial Water Technology Conference. That's in May in Niagara Falls, and the Esri UC Annual Conference in July in San Diego. We have proposals in for both of those, so we hope to present. If any of you are planning to attend these events, let us know, reach out to us, and we're happy to connect with you in person and continue the conversation at these events. With that out of the way, we're happy to take any questions if there are any.
All right. Thanks. And it looks like Dave is going to see you at AWRA too. So yeah, well, if there are questions, put them in the chat or wait. And after Colleen's presentation, then we'll just kind of open up the floor and let folks ask online. But before we lose too many people at the top of the hour, I'd like to turn it over now to Colleen McNally Murphy with the San Mateo Resource Conservation District, and she's been the project manager for this DCA proposal that was accepted and is in progress.
Yeah, thanks, Jane.
Right.
Hi, everyone. Okay, I am going to share my screen and keep my fingers crossed here. Can you see the correct
Yes.
full screen? Okay.
You got it. Yeah, thank you.
Great. Thanks everyone who has already presented. I'm really glad that you covered the technical side of things because that is not what my presentation is about. I'm really here to talk about partnership and how we have put together our project to do this hydrographic data mapping. So the purpose of the project is just very briefly for the Santa Cruz Mountain Stewardship Network, updating the hydrographic data layer that we have now for Santa Cruz, Santa Clara, and San Mateo counties in the Santa Cruz Mountains to improve land stewardship decision making. And as has been described, the current data is pretty insufficient for our current needs. And so this is just a really nice opportunity that people are pretty excited about. So the value of the project, I mean, this is just sort of a quick bullet point list, and I won't read all of them. But these data, you know, as has been described, but just to really emphasize, I mean, it's so critical for climate resilience modeling, for managing resources, if that's, you know, fisheries, rangeland, timberlands, et cetera. But it's really important because water, sort of more than anything else, doesn't recognize land boundaries, you know, property boundaries. So in order to really understand how all of this stuff connects and impacts people and wildlife, it's really important that we work together to do this. So this is where regional coordination becomes really important. So our project area where we're mapping is here in the, again, so the Santa Cruz Mountains run sort of along this county line right here, if you can see my cursor, but we've got Santa Clara, Santa Cruz, and San Mateo counties. And we were trying really hard to get the counties covered, but of course, watershed boundaries are not the same as county boundaries. And so, you know, we got as close as we could. You can see there's a little gap here at the top of Santa Clara County, and then we ended up sort of going over the line into a little bit of Monterey, San Benito, Alameda, and San Francisco counties as well. So who is our project team? We have California State Parks, Peninsula Open Space Trust, the Mid-Peninsula Regional Open Space District, Sempervirens Fund, San Mateo Resource Conservation District, which is my organization, and then, you know, funding from USGS for the, or through the 3DHP, excuse me, program. And the NV5 is doing the technical side of the work. Thank goodness. Not my specialty. But I want to just really talk about sort of how this came together a little bit too. You know, we have, so for state parks, post, mid-pen, sempervirens, and our RCD, it was really important that we design a project that fit each individual entity's needs sort of geographically. So I'm just going to bounce back here to this map. You know, not everyone works in the entirety of these three counties, but this is a partnership. And we also were working not just with these organizations, but as part of the entire stewardship network, which I'm going to sort of give you the whole list of who's in there. But, you know, these are the groups that own a lot of land too. And so backed in the, in these counties and so, or who have a management responsibility, stewardship responsibility. And so it just really helps to be able to make good decisions, to have good, accurate data. So the Stewardship Network, it's 25 organizations that collaborate and coordinate on landscape stewardship on a regional scale with the mission of cultivating a resilient, vibrant region where human and natural systems thrive for generations to come. And this, you know, there's a big swath, maybe, organizations that you wouldn't necessarily expect to be working together who really have come together. So we have government agencies working at different levels. So the Amah Tribal Band, different special districts. So that includes conservation districts, the Open Space Authority and Open Space District. We have a couple of state agencies there, federal represented with Department of Interior, county parks districts from three counties parks, 3 water districts, the Habitat Agency there in Santa Clara Valley. We have environmental nonprofits. We have the Girl Scouts, academia, 3 different institutions represented there, and then also industry, timber and logging. So it's a big effort. And because this is a regional approach to management, each of these member organizations that's in the network, they're going to sort of focus on one thing or another. But so it's nice then to get sort of the smaller group that can step forward and really lead. Okay, so how does this fit into the sort of broader vision? If we zoom out, so we've got sort of our project team, and then we've got the network working together, but then this really feeds into the Pacific Veg Map, which I'll talk about momentarily, but this is a broader regional effort. And then what's happening across the state in California, to map the whole state, and then nationally through USGS, but then recognizing that our specific area does overlap with some priority mapping areas identified by National Park Service, Fish and Wildlife Service, and Bureau of Land Management. So the Pacific Veg Map, I really wanted to highlight, that was one of the key reasons for us when we started thinking about this project, is that we have worked a lot on the Pacific Veg Map over the years and contributed to it, but then this is a gap in what currently exists. Excuse me. So you can see here that this goes well beyond the Santa Cruz Mountains area. We've got 10 counties represented, currently 227 data sets covering, fine scale data around like vegetation, topography, wildlands, fuel, the built environment, all sorts of things. And I really want to highlight that this effort includes many more partners and funders than just who's in our stewardship network. So we sort of have like concentric circles of partnership happening here. Excuse me. And then sort of moving into just sort of to put a bow on it, why partner to move forward if you're interested in doing this kind of a project in your area. We couldn't do it on our own. Each of the organizations that's working together on our project team, everyone has sort of this interest or that interest, but no one has the capacity to do it individually. And it really took us saying, okay, well, who can contribute funding? Who can contribute with, communications here, or, project management, and just sort of pulling the different pieces together. And, sort of stepping back to what I said around designing it so that it fits everyone's needs. We also actually are working with NV5 sort of on top of our 3DHP, requirements and contract with USGS. There are some additional attributes that were important to some of our team, like bank full width. Like, how do we, we want to make sure that we're generating data that we can put on the veg map that people really will use sort of, immediately on the ground. And so we were thoughtful in how we designed it. And then also just, again, why partner? So that we can work together. This really feels like a many hands make light work kind of an effort. And it's a big lift, but thanks to all the people who have already spoken today, who've done the technical side, then it's sort of our turn to say, okay, well, how can we work together to implement it on the ground at our region. So I'm gonna wrap up right there. But there is my email. Please feel free to reach out if you have any questions, and I will pop the link in the chat to the Pacific Veg Map as well. But thank you.
Awesome. Thank you so much, Colleen. There is a question for you in the chat, but I did advertise that I was going to stop recording for the Q&A and open discussion because I want people to feel a little bit more, relaxed about what they're saying, because we do intend to post the rest of these presentations online. So I will stop the recording now, and as I end, I'll just say, watch the CGIA.org website for the recording link and other information about that. And thank you to the sustaining members of CGIA and the regular members of CGIA for supporting this effort. And so I'll stop recording and then we'll take John Paul's question. Thanks.